Hi everyone, today we're going to be talking about graphing exponential equations. So exponential equations have this format: y is equal to a times b to the power of x. And so all of these exponential equations that we're going to be graphing look like this. And when we read them, the easiest way to kind of read them is to say like this a, the number that's in front that's not to any power, not to the power of x, is considered our y-intercept. So it's going to be where it crosses the y-axis. It's like our starting point. That's the way I like to think about it. Then in our B, now this is kind of weird, but I'm going to call it our slope. It's not really our slope, but it is like what I multiply by every time, or it's how much bigger it gets. So we can kind of think about it like slope, but we've talked about slope with linear equations, and it's not a straight line, it's a curve. And so it's not really a slope, it's more like what it's being multiplied by every time. So the easiest way to do this is just to start with some examples. So the first example, what we need to do on here is graph this equation. Now there's a couple of different ways that we can graph it. The first way being a table. So we can totally do this. We're going to draw an x and then a y. And we're going to just come up with some numbers for x, like -1, 0, 1, 2, and what we're going to do is plug those values into my equation and see what you get out for y. So if I plug in -1, I would have y is equal to 3 times 2 to the -1 power. Now that gives me, if I plug that into a calculator, what that's going to give me is 3 over 2, or 1.5. Now let's do that again, but instead of plugging in -1, now I'm going to plug in 0 just to see what happens when I put 0 in for x. Well, when I put 0 in for x, 2 to the power of 0, or anything to the power of 0, is actually 1, and so this ends up being 3. And then I'm going to take away the 0 and I'm going to plug in 1 now, and when I plug in 1, if I plug that into a calculator, I'm going to end up with 6. And then the last thing I'm going to do is plug in 2. And so I would have 3 times 2 squared. If I plug that into a calculator, I'm going to get 12. So now I have this table full of values, and potentially I could make that table will go bigger. We just need a couple of points to kind of see where the graph is going to go. And so if I graph with this table, I'm going to start with -1, 1.5, which means I'm going to go back 1 on my x-axis and then up to 1.5 on my y-axis. And then I'm going to do 0, 3. So didn't move anywhere on the x, but I did go up 3 on my y-axis. And then 1, 6 would put me, let's see, 4, 5, 6 right here. And 2, 12 would put me off the graph. And it would be kind of maybe like up here, right? So then I can connect all of these dots. What's going to happen is the graph ends up looking kind of like this. And it kind of slopes down like that. You could have more negative numbers to double check that it slopes down and kind of flattens out at the end, but I promise you it does. So that's one option for graphing this, is with a table. And then I'm going to actually show you the second option in the second example. So for my second example, we're going to actually, let me backtrack up here, use this kind of this formula up here where we decided that the first number was our y-intercept and then b was kind of like our slope. So our first number in this case is 5, which means that's our y-intercept. So what I'm going to do is go up 5 on my y-axis and put a point there. And then our slope is 1/3. Now that, remember, we talked about it, it's not necessarily a slope. It's kind of like how much we multiply by every time. And so what we're going to do is, for the first one, we would say 5 times 1/3, which is 5/3, or like 1 2/3. And so that's this one right there. Like if I move over 1, now I multiply that 5 and 1/3. Then I can do that again. I can take that answer, the 5/3, and multiply it by 1/3 again to get what would happen at the second place, or when x is equal to 2, which would give me 5/9, which is like right here, right? And I could even go backwards. So when I go backwards, like if I wanted to figure out what happens when x is equal to -1, instead of multiplying by 1/3, I'm going to multiply by the reciprocal, which is 3. So 5 times 3 is 15, which is off the graph, but it would be like up here. And so now it looks really similar to our first graph, except for it's backwards, right? The reason why it's backwards, or the other way, is because now my slope portion is a fraction, whereas up here my slope portion, that 2, is a whole number. So when you have a fraction, it looks more like this one, and then when you have a whole number, it looks more like this one. Okay, so that's how we graph them based on the equation. Now what we're going to do is actually look at a graph and write the equation. So this is the easiest if you can use that formula that we've been talking about, the y is equal to a times b to the power of x. Because we automatically know that a is our y-intercept, and those are pretty easy to find. So in this case, for example number 3, a has to be equal to 3 because that's our y-intercept. Now, to find b, the first thing that I notice is that it's going down. It looks like that b has to be a fraction, so we know it's going to be some fraction. And to kind of decide, and I know that my artistic skills are not the best, and so it's easier to see on your graphs, but to decide, the easiest way to do this is to take what happens when y is equal to 0 and then y is equal to 1, and see what happens. So when when x is equal to 0 and when x is equal to 1. So when x is equal to 0, we know that y is 3. And then when x is equal to 1, it's 1.5. So to go from 3 to 1.5, what did I have to do? Well, I could have subtracted 1.5 or 1.5, and it would have given me 1.5. That's fine. That's great. But remember, we've been talking about this exponential equation, how instead of adding or subtracting something, it's multiplying by or dividing by something. So if I'm going from 3 to 1.5, that's me dividing by 2. 3 divided by 2 is 1.5. And so now that I know that it's dividing by 2, that's the same thing as multiplying by 1/2. So b is 1/2, which means my final equation is y is equal to 3 times 1/2 to the power of x. Now, if that's hard for you to see, particularly when you know that equation is going to be the slope portion is going to be a fraction, the other thing you can do is look at what happens when x is equal to -1, which is right there, and then when x is equal to 0. So when x is equal to -1, the y is 6, and then when x is equal to 0, the y is 3. So to go from 6 to 3, that's a little bit easier to think about. Well, 6 divided by 2 is 3, so my slope is still that 1/2. Okay, now let's do that last example. So once again, we're going to use the original formula for our exponential equation, y is equal to ab to the power of x. And our a is our y-intercept, which automatically we know is 2. And then b is kind of like our slope. Because it's going uphill or it's getting bigger, we know that our slope has to be a whole number, not a fraction, or a number bigger than 1, really. And to decide that, we're going to do the same thing as we did on that example number 3. We're going to look at what happens when x is equal to 0 and then when x is equal to 1. So when x is equal to 0, our y is 2. And then when x is equal to 1, it looks like our y is 6. So to go from 2 to 6, what did I have to multiply by? Well, 2 times 3 is 6, so our b must be 3. And we could double check that. My graph is too small, but you could double check that with what happens from when x is equal to 1 to x is equal to 2. So x is equal to 1, when x is equal to 1, your y is equal to 6. But when x is equal to 2, your y is equal to 18. And so to go from 6 to 18, what do we have to multiply? We had to multiply by 3. That's what we already thought. And so that remains our answer. So my final answer is y is equal to, not a, let's try that again. Y is equal to what a is, which is 2, times 3 to the power of x. And that is how we deal with exponential graphs.